Here's a question I love to pose in regular classes, face-to-face classes. And I have a little disadvantage here, and so do you, doing this by video, because I can't speak with you in real time and interact. But oh well, we'll just do our best. So here's where I'm headed with this. Is it true that 2 is less than 4? Of course it is, because 2 objects are fewer than 4 objects. No one's going to argue about that. And so my question becomes, what happens to -2 compared to -4? And I think it's a wonderful question. Most students do know the proper answer. It's supposed to be greater than. But why should -2 be greater than -4? I've had some students say, well, it's it's closer to 0. Oh, wait a minute. If that's closer to 0 and that makes it greater than, then why doesn't 2, since it's closer than 4, why isn't that greater than? That doesn't hold up. I also like to point out, but wait a minute, isn't -4, isn't that a bigger looking number than -2? 4 is greater than 2. Why isn't this number greater than that number? And so, how do you resolve those objections? And I don't know if this occurred to the first people who seriously considered the negative numbers, and the negative numbers, they pretty much go back around 600, 700, 800 years, we'll say, maybe a little farther than that. But for the longest time, people, mathematicians, didn't want to mess with negative numbers, and they were also philosophers, and you might reasonably say, well, look, I can't see negative quantities, then why should I even mess with these things? They're just, it's sophistry, it's a cleverness that has no use in our real world. Well, people finally got over that and discovered how useful negative numbers are to our real world. And so at some point, they had to resolve, how do you place these in order? And, of course, this is greater than. The answer lies in looking at the number line. So there are 2 reasons, actually, to have negative numbers. And one reason is if you have a scale of numbers that is open-ended, unlimited on either side, then somewhere you have to put 0, and on the other side, we have to put something. Well, this is where the negatives come from. The other reason to have negative numbers is because we have processes that go forward and backwards, up and down, forward, backwards. And in order to represent motion in say 2 dimensions, then we need negatives and positives to indicate direction. So negatives are there for directionality. They're there because open scales have to have a negative side. All right, so at some point, our math culture decided to put the positive numbers growing on the right side and cause the negative numbers on the left side to grow as a mirror image to the right side. And so we grow -1, -2, -3. Well, the way this less than and greater than works, it's truly defined as direction on a number line. And so where is 2 in relation to 4? There's 2, there's 4. 2 is to the left of 4, and so 2 is less than 4. How about -2 and -4? Well, -2 is to the right side of -4, so that makes -2 a larger number. Or you can look at it the opposite. -4 is to the left of -2, that makes it less than. So actually the definition of less than or greater than, if you were to pose a formal definition, I believe you would have to settle on something like this. It indicates an orientation on our number line. And literally, less than is to the left of a number. All right, well, that to me raises a great observation here, because how could I jump from 2 less than 4 down to this stage? And we can do that by multiplying each side by -1. So if I started with 2 is less than 4 and multiplied both sides by -1, then it turns out we'll get -2, -4. It means that we're going to need to switch the less thans and greater thans. Gotta look at my watch because I have a dentist appointment shortly. And so when multiplying by a negative, it turns out, and this works in all the problems we work with inequalities. Anytime you multiply an inequality by a negative number, then you've got to switch the inequality symbol. So this is the new rule about solving that you really need to learn. And it also works for dividing. So when you multiply by a negative, divide by a negative, then you've got to switch the inequality. And there's a third reason, right? If you just switch both sides, if you just swap them, then you also have to turn the inequality symbol. All right, so 3 rules for changing inequality symbols. Now, as far as anything else, when you're talking about inequalities, if you add or subtract numbers to an inequality, it doesn't change the orientation. For example, if I added 1 to both sides here, then I get 3 and 5, and 3 is still less than 5. And the net effect is that 2 and 4, when I added 1 to both sides, slid over to here, became 3 and 5. So adding a number to both sides of an inequality shifts it to the right. And if we subtract it instead, it would shift both items to the left. So if I took 2 and 4 and subtracted 2 from both sides, I would get 0 and 2. That would shift left. The important thing to notice here is that by adding or subtracting a number to an inequality, it shifts both sides, but does not reorient them. It doesn't switch them around as multiplying it by negative does. All right, so this is called, by the way, geometrically, that's called a translation. Geometric translation. Now, multiplying by a positive number won't change the inequality either. So, for example, let me make some room here. If I started with 2 and 4 again, 2 is less than 4. If I multiply both sides by 1/2, then I get 1 is less than 2. So what happens, multiplying by 1/2, then these numbers switched over to here. So they went from being this far apart to that far apart, but still, this number is to the left of the other. In other words, you see how I demonstrate this. When I multiply by 1/2, it did move the numbers, and in that case, it moved them a little closer to one another, but it did not reflect them. So we rescaled, but did not reflect. Multiplying by a negative reflects, and that turns out to force us to switch the inequality symbol. If I multiply by a larger number than 1, it would expand the distance between them, but it would still keep the number on the left. And so multiplying by a positive does not change an inequality. Adding or subtracting does not change an inequality. What does is multiplying or dividing by a negative number, or switching both sides. All right, so if you can keep those rules down, then solving inequalities is otherwise just like solving regular equations.